the reference angles are, of course, highlighted in yellow. Questions? Once, twice, thrice. Excellent. One of the first questions on your Genecta tomorrow will be a question like that. I expect 30 out of 30 of you to get it right, since you all just said you're cool with this. Excellent. Given the ratio, what are the three ratios? Sine, cos, tan. You know sine to be O over H or Y over H. You know cos to be A over H or X over H. You know tan to be O over A or Y over X. And you know H to be the square root of X squared plus Y squared. So, given the ratio in sound position with its terminal arm in the stated quadrant, find the exact values. Where is quadrant 2? Top left. Boom. Does it matter where I draw the line? No, because it's a sketch. What do I know about this? What is this distance right here? So what is it? 3. What is this distance right here? X. So it is -2. What is this distance right here? Square root of 5. So this is, we already have cos. What is the sine? Root 5 over 3. What is the tan? Root 5 over -2. Is everybody good? Pardon me? What? Of course I'm going to do B. I'm going to leave you hanging. Oh, find theta. Of course, yes. So you would have done shift sine, shift tan, shift cos of any of those. And that would have given you what? It would have given you the reference angle, which was 48 point blah, blah, blah. Was it more than 48.5? So it's 48. Where is the 48? I'll give you a hint. Where is the 48? Right there. So what is theta? 132, if we round that to 48. Yeah? Quadrant 4, down there. Sine. What is this? 3. What is this? -1. What is this? Root 8. Since I already have sine, I just need cos is what? Root 8 over 3. Tan is what? -1 over root 8. And theta is? What? No, hypotenuse can never be negative. Because, and you weren't here for this, the hypotenuse is a squared plus b squared, right? Well, if this is b squared, it's -1. What's -1 squared? Well, I'm asking Brendan. I know you know because you were here for it. 1. And this, root 8 squared is 8, yes? So they're both positive. And when you square root, you get a positive number. The hypotenuse is always positive. So what was the? 341. If you do the right one of these, you're going to get 341. But some of them will give you a negative of 20 39. You have to know, obviously, which is the right answer. Yes? Because remember, we start counting from the quadrant 1 of the x-axis. Yes.
If you divide like shift and -1 divided by 3, you got a negative.
Where would you, what? Yes. You got a negative number, which means you found the reference angle. That's what I'm saying, Ganika. You have to know, when you get the answer, you have to know what makes sense. So on your calculator, if you do shift sine -1 divided by 3, you get -19. Yeah? But if you do shift cos of root 8 divided by 3, you get positive 19. Why? This would be up here, wouldn't it? Your calculator wants to give you the answers when it can in this quadrant, right? So as soon as you saw negative, you knew, since we were in this quadrant, this had to be where it was. So it's 360 minus 19. Good?
Wait, so triangle, it's
No, theta is all the way around from x. 319. The angle in the triangle is 19. The angle of theta is 341. Quadrant 3 down here. Where's the negative, or where's the 3? But how can that be? That decimal would be down on the y-axis. So what is this? -3. What is this? -5. How do I end up with a positive tan? -3 divided by -5 gets me positive. What's the hypotenuse? Square root of 34. So, sine is what? -3 over root 34. Cos is what? Now, what do you... Yes, Suhan?
Okay, so tan is x over y.
Mm-hmm.
X is 3.
No, tan is y over x.
Oh, it's y over x.
Yes. So, when you go to your calculator, this angle of theta must be more than 180, yes? Right? So when you go to your calculator, which of these three will give me more than 180? Shift tan 3/5. Crap, that didn't give me 180. Okay. Shift sine -3 divided by root 34. Well, this will obviously give me more than 180. Shift cos. Cos will give me the right answer. There it is. Do I need to do all of them? Of course not, if you understand what is going on. Right? Oh, and lastly, quadrant 3, cos 8, -5. That is square root of 64 and 25, square root of 89. And figure it out. tan is root 89 over negative 5. Sine is root 89 over 8. And theta is 39. So that is 119. I'm sorry, 219. Yeah? And lastly, or not quite lastly. Okay. Draw a diagram to represent two locations of theta. Where are the two places theta? Yes? Oh, did I use 8? Oh, I should have subtracted, yeah. It's square root of 64 minus 20. Yeah, it's 39. Thank you. And then that changes that. What's this? What's theta then? What's theta? Theta was 30?
Like 231.
231? Well, I don't know because nobody's telling me. You get theta the same way you always get theta. Shift, whatever one you want to do, cos negative 5 divided by 8. Okay, so can it be 128? Of course not, because 128 would be up here, wouldn't it? Which means this has to be 52, correct? Right? Because this would be 180 and that's 128. But I can't be in that quadrant. I have to be down here. So this must be the 52. So this must be 232. Because that would be 180 plus the 52. Okay? Once again, your calculator is giving you all the right answers, but you have to know how to apply it. Sine is positive 5/13. Where are the only places it can be? First and second. Since it's 5 over 13 and sine is y over h, those must be 13. Those must be 5. Yeah? All right. What does that make this? 12. What does that make this? Negative 12. So my coses are plus or minus 12/13. What are the possible values of theta? First theta is there. What happens when you shift sine 5/13? It gets you what? As I hear tick, tick, tick as people go to their calculators now because they didn't do their homework.
It gives you
23. So if that's 23, what's this?
158.
23, what's this? 157. So, because theta counts from where? From the initial arm to the terminal arm. And since I had two possible terminal arms, I have two possible reference angles. Is everybody cool? Y will form the other trigonometric ratios of theta. Right? Y will be part of tan and sine. Is y going to be part of cos? Not at all. We had to find the cos. Everybody's good? So now, we've already found our two values of theta. Yeah? Yeah. Now, can I from this question, as it is written now, know which of those thetas I am referring to? Can you know from this question, as it is written, which of those thetas I want? No. Because they are both the exact same, yes? If I told you it was the theta in quadrant 2, which one do I want, red or green? I'm going to try this again. The red one is there. The green one is there. I want the theta for the terminal arm in quadrant 2. It is the green one. And lastly, if this is cos, I want all possible values of theta. So, what can I do with this information to find one of the values of theta right now? Preston. Yes, and hit which buttons? Shift cos. So I can go to my calculator and I can hit shift cos soon as it turns on because, quality. Shift cos -1 divided by 3. Yes? And this is going to give me a value for theta, isn't it? 109. Agreed? All right. So we now know that if I go out here to 109, I'm going to have a cos of -1/3, aren't I? Yes? What is this green value right now? No, what's the number for this green value? 109. What's the number for this value? 71. Now, if cos is negative, can it be out here? No. Can it be here? Yeah. Can it be here? No. Because cos is positive in there. C-A-S-T. So here is where the other cos must be, correct? If this is 71, what's this? 71. So what then is this? 251. Is everybody good? It is all based on 90 degrees and the 4 cardinal spots. Yeah? Excellent. Everybody is actually good, yes? Okay, now, stop for a moment. Stop for a moment. The Genecta-Gazoink stops at page 81. Can you do trig on the pink triangle I have just drawn at the top of the page? Yes. Could you do trig? If you add any sort of labeling on anywhere on the triangle, could you do trig?
Yes.
Excellent. Easy peasy, correct? All right. Do you have a method to do trig there? Yes, you do. What is it? You cut it in half and create 2. Yes? Is everybody with me? All right. Now, of course, you need to be aware of the fact that all that is happening here is I have this triangle. I should have changed colors. I have this triangle mashed up against, how did that happen? Mashed up against that triangle, yes? To create one solid triangle. Agreed? Now, if I don't cut this in half, if I don't cut it in half, name the sides. What's this guy? What's this guy? What's this guy? Excellent. And do we not have proof from a right angle triangle that the angles, the ratios, and the sides all share some kind of relationship? Because if it works in this triangle, why wouldn't something like that work in this triangle? Agreed? Everybody see that? Does that make sense when you see that? It doesn't? If I told you that this was 32 and this was 16, does that make sense? What would you put in for little a? What would you put in for big A? And what would you punch in your calculator? So does it make sense? Great. Watch. Just. Ah! Not what I wanted to do. Everybody happy? A, B, I lie. Let's go this way. A, B, C. Everybody cool? Until today, and until you saw this, if you had to find information from this triangle, you would have had to build this, correct? Everyone agree? All right. And if I gave you this of 32, and I gave you this of 19, right? And I gave you this of 14, you could have figured it all out, correct? What would you do? Which side would you be working with right now, left or right? Why? Because you have a side and an angle. Agreed? Okay. Now, I would. What would you do on the left here? You would get the vertical side, wouldn't you? Using what? Sine. This vertical side would be sine of 32 would equal, I'm going to call it x over 19, correct? Everyone agree? And then what would you do with that? 19 sine 32 would equal x. Yes? Is everyone cool with that? All right. Now, over on this side, what could you do right now? Oh, you can. Could you find this angle? How? Shift sign of what?
Once you find it, well, x is...
Well, you don't need to find x. You've got x. It's right there.
So you would do shift.
Is everybody cool with that? What Ganika said? Yeah. Everyone's cool with that? Okay, now, that's one way you could have done it. If you had no more information, yes? Everybody cool? Okay, now, wait a moment. You don't have to erase that. I just want a little more space. What if I told you that this side was 58? Now what can you do on the right side? Exactly the same thing, can't you? Doesn't on the right side 14 sine 58 equal x? Doesn't it? Does everyone agree? Okay. If 19 sine 32 equals x and 14 sine 58 equals x, what do I know about 19 sine 32 and 14 sine 58? That they are equal because they both equal x, yes? Now, if I wanted to solve the left side of the equation, what would I do to get rid of the 19? I would divide, correct? To keep it an equation, where else would I need to divide? On the right. I would divide that by 19. Agreed? How would I get rid of this 14? Divide both sides by 14, yes? Now, have I gotten rid of this 19? I have, right? Because I divided by 19, yeah? So that's gone, agreed? Have I gotten rid of this 14? It's gone, agreed? 32, 14. 58, 19. Two ratios, yes? If that equals that, and I'm in a triangle, what do I automatically know about the third angle, which would be sine C over, what's this down here? Lil c. Because if those two are equal, the third must be as well. And that gives me that. Because order doesn't matter. Now that's why it works. None of you care why it works, although you should, but none of you do. You only want to know how it's going to help you out. So let's do so. This question here is blank, yes? What do I need? Label it. A, B, C. Does it matter where I put A? I'm going to put it here. Everyone agree? Okay, where should I put B? The way I've drawn it. I should put it over here, yes? Because this has to be bigger than 90, the way I've drawn it, yeah? Everybody cool with that? So this must be what? C. Everyone agree? All right. Where is AB? So that's 6. Everybody cool with that? Okay. I want to know AC. Where's that? This would be little b, wouldn't it? Lil b. What would this side be? Lil a. How can I solve it? Well, there's no 90, is there? So I can't use SOHCAHTOA. But we have just proven this, haven't we? So let's check. Do I have a big A? I need the little a, don't I? So, what would I write? Little a over sine 40 equals, what's little b? Little b is little b over what? Sine 75. And do I know little c? Yes, I do. What is it? 6 over, do I know the sine c? Yes, you do. 180 minus 75, which is 105. Minus 40, which is 65. I'm doing something on purpose to you. This has to be 65, doesn't it? Now, the way I've drawn it, is it 65? No, it's bigger than 90, isn't it? Okay. Call your minds back to the SOHCAHTOA unit. Does the actual shape of your drawn triangle matter? No. Because the angles and all the relationships are still the same. So what is going here? Sine 65. Agreed? Now, can I solve that? I have b over sine 75 equals 6 over sine 65. What is your job whenever you see a variable? Isolate it, yes? So how are you going to get this sine 75 out of here? You're going to multiply both sides by sine 75, aren't you? It's going to be over here, yes? So 6 times sine 75 divided by sine 65, yes? Will that get me b? Yes, it will. It's algebra, right? How will I then do this side? Oops, sorry. What will the pink side be? It's going to be a over sine 40 equals what? And how will I solve that? Right? Now, Ganika.
Okay, so how come you have like A and C? Like, why can't you do A and B together?
You could have.
You could.
Once you had this answer, you could have used that there. I'm only using C because I had no unknowns. And I don't have to write out some crazy long decimal because I got C right there. No. Now, hold up a second. If I do this on my calculator, and I've shown you guys how to do this before, you always, when you have fraction equals fraction, multiply and divide what's left over. Multiply and divide what's left over. So I go to my calculator and I do 6, when it turns on, 6 sine 75 divided by sine 65. And I get 6.39 for B. Everybody cool? You all just watch it happen, right? So B, 6.39. Yeah? What's this one going to be on the left? 6 sine 75. I'm over here. 6 sine 40. Because I want to use the 6 because it's exact. Yes? It's not the 6.39 that's rounded. Divided by what? 65. Not sine of 5. 65. And what do I get? 4.3, yes? Now let's stop for a moment and think about this. We know some stuff about triangles, don't we? We know some stuff about 90-degree triangles. What do we know about them? They have hypotenuse, right? What do I know about the hypotenuse? It's the biggest side. It's biggest. Yeah? Excellent. This is 30 degrees. This is 60 degrees. Which leg is longer? No. Legs. Which leg is longer? You do know this. Vertical or horizontal? Vertical leg is longer, yes? Is it as long as this? It's the second longest, yes? What do you know about this one? It's the shortest. Now, if something happens once in math, how often does it happen? Always. Is 90 the biggest angle?
Oh wait, I thought you were saying like overall.
Is 90 the biggest angle? What's across from it? Or the biggest side. Is 60 the middle angle? What's across from it? The middle side. 30 is the smallest angle. What's across from it? Shortest side. Now, what's the biggest angle in this fake triangle that you drew? Because I didn't draw it to scale, did I? What's the biggest angle? 75. Is the biggest side across from it? What's the smallest angle? Is the smallest side across from it? What's the middle angle? Is the middle side across from it? So did we do it right? Excellent. What does solving the triangle mean? Find all sides and all angles. So, woo! Slow it down there, big stuff. What do I know? This one's a little bit harder. What do I know? I have an angle, yes? What is that angle? It's 35 degrees and it is labeled D, yes? What else do I know? There's two other corners. What are they? E and F, correct? Do I have a triangle yet? What do I need to do to make a triangle? I need to connect them. Which one's E, which one's F? Okay. Thomas wants right to be E and up to be F. Everybody cool with that? Okay. What else do I know? Little e is what? Where's little e? Left to right or to bottom? There's 12. Where's little d? 7. To solve this, what do I need? I need two angles and a side, correct? If I'm going to solve this, I'm going to need to use the sine law that we just learned, yes? The sine law compares what and what? What does it compare? It compares a side with what? Which angle? The opposite angle, right? So if sine A goes with little a, but Mr. Meyer, there are no A, B, and C in this line. Does it matter? Where will sine of D go with? Little d. Right? Now, could I put it down there if I wanted to? Sure I could, as long as I keep that order all the way through. What does that have to equal? Sine F over what? Little f. What does that have to equal? Sine E over what? Can you fill in some of those numbers? What? Equals. Can I do anything here? No. Can I do anything here? Which one? Sine big E over 12. How do I solve that? Yes, I got to do that multiplying thing. What is it? 12 sine 35 divided by what? 7 will get me what? Sine E. Do I want the sine of E? What do I want? I want the angle. If I know the sine, how would I get the angle? Shift sine. You're looking for everything. In this case, it was easy to find the angle. What then is E? You all have calculators. What's E? I love it when people don't try it in practice and then ask me how to do it. That's my favorite. Sure. Who has an answer for E? 79.5, which we would round up to. If I know E is 80, I know. I don't want to show you doing I've recorded what you need to hit on your calculator. I want you to do it. But most people are talking to each other. So then when I ask them to do it in 10 minutes, when I go to the next page, they're all going to sit around and not do it and then blame me that they don't know how. Or they're going to ask for help. And then I'm going to say, well, can I see your notes? And they're not going to have notes. Then I'm going to say, well, why would I help you? Because you didn't do notes. And then they're going to say, you're supposed to. Then I'm going to say, well, shouldn't you have done your part of the bargain, which is do the frickin' notes? But some people aren't. Which is why I help you with a smile on my face when you screw yourselves over. Right? Right. Now notice I'm not actually talking to any of the people I'm angry with. I'm actually talking to you because I know you did what you're supposed to do. So you know that this doesn't apply to you. But I'm speaking really loudly in hopes that everybody else figures it out. Except ironically, people that I'm angry at still haven't shut up and are still talking to each other about garbage and still don't get the lesson that I'm actually trying to get across to them, which makes it doubly funny for me. So, if you know that, do you now know this? I know that, but you don't need to see it, because if you have done your work, you know the angle right now. So you know the third angle, because that's the only thing you can do without a calculator. You're welcome to. Go ahead. I don't know, will you? You're welcome to try. Since all of you run out of time, if I give you a question on addition, maybe you should be learning the way that makes it go faster, don't you think? Don't you? So maybe you should really have paid attention to this thing that's going to make it go way faster, right? Yes, you could. You're welcome to. Suhani. Of course you'll get the same answer. Exactly the same stuff, because math is math. Is anybody going to tell me the third angle yet? Because you don't need to see it. 65. Now I will wake the screen back up, because now I have proved that somebody did something. When you do this, you get 80, which automatically finds you the third angle, because all of you can subtract in your heads. Now, you now have F. What can you put there? 65. So you already had this pairing, didn't you? And now you have, I will change color. sine of 65 over what? Little f, because I don't know little f. What do I see? How will I get f by itself? Not Pythagoras. You cannot do Pythagoras on a non-90 degree triangle. You will multiply 7 by sine 65 and divide the answer by sine 35. And that will get you little f, which I drew looking like a 9. F. And of course, you will do that on your calculator and get what? Preston, 11.1. And then, of course, you will check and see, is the largest angle across opposite the largest side? Yes. Is the middle angle opposite the middle side? Yes. And is the smallest angle opposite the smallest side? Indeed. And how difficult is trig now to do if you don't have a 90 degree? Not at all. As long as you know one thing. There's a condition that needs to be met. What is it? For me to do this, because this is what you started with, what had to happen? Preston? You needed two sides. You need one side and its opposite angle. If you have that pair, you can do sine law. Everybody good? Remember, sometimes you're left with a sine, so you have to shift. As always in trigonometry, when you're looking for an angle, big E, you add the shift sign to get the angle. When you're looking for a side, little f, you didn't. Just like in SOHCAHTOA trig. Now, Jasleen asked, couldn't you just always split it in half? And of course the answer is yes, provided you have enough time to do so. Since a great many of you are often short on time, I would recommend learning this infinitely faster way to do it. But there is no way I can force you to. If you feel you would rather split it in half, do SOHCAHTOA on this side, then SOHCAHTOA on this side, and Pythagoras on this side, and then add those two sides, and then add that angle and that angle, go ahead. You're welcome to it. Because apparently, you would rather not learn this, because you can do that other thing. That's cool with me. Don't care. There is your work. Page 83. There are no answers. When is it due? Wonderful. Will I give you some time tomorrow? Of course I will. Because what else is happening tomorrow? Your Genektigezoink, which is going to happen when you walk into class. Some of you will be done quickly, which means you will start finishing this. Okay? Okay. Go.